Welcome back. This is Pradeep Kumar from Department of CSE IIT Bangalore. So in the last discussion, we have seen the access matrix, how to represent the domain, how to represent the objects, and how to put the right set as a cell in that matrix. So access matrix is nothing but, so we are going in that access matrix, we are going to represent row wise the domains, column wise the objects, and the cell is nothing but the right that we are going to set it. Right in the sense, right permission, that is permissions or privileges or access permissions, nothing but read, write, execute, print, copy, control, transfer, all these, including special permissions. So today we'll see about implementation of that access matrix. In general, so this particular access matrix we are going to implement in the form of sparse matrix. What is sparse matrix? Sparse matrix is nothing but which contains very few non-zero elements. In general, if you consider any matrix, however, the matrix is a combination of rows and columns. With respect to access matrix, rows we are going to represent domains, columns we are going to represent objects. So now we can implement this access matrix in the form of sparse matrix. Nothing but in general it is sparse matrix because only few cells will have a non-zero elements. So what are those non-zero elements? Nothing but read, write, print, nothing but the access permissions. That is one kind of implementation. So in general, we can implement all these access permissions in the form of matrix, and that matrix may be a sparse matrix because it may not be possible or it may not be sure at all the time all the domains will have access permissions for all the objects. So that's why it may be a sparse matrix. Second, and then the first option is we can represent or we can implement the access matrix as a global table. Even global table, when we say table in the sense, again it has rows and columns. So how we can store this with respect to a global table? So we can store in the form of ordered triples or triplets. There are three individual attributes in that particular row, that is domain, object, and rights set. Please follow my cursor on the screen. So when we say order triplets, it should contain domain, nothing but the which particular domain wanted to have access on a particular object, that particular domain name is supposed to have. Second one is object, that is which object should be considered for read, write, and execute. Then we have rights set. So this rights set is nothing but either a group of access permissions, say read, write, execute, all those, or only few, or only one, or nothing. So that is, we can represent this particular kind of access permissions in the form of triples. Nothing but it has three attributes in that particular set: domain, object, and right sets in the table. So how we can enter this set of values? Nothing but a requested operation m on object oj within domain dj, then we're supposed to search the table di and dj and rk. So di, oj, and rk. That means, for example, a requested operation. For example, one particular domain wanted to have operation, say read operation on object oj within domain di. So then how it will look in that particular global table is dj, that is first is supposed to set up the domain, then oj the object, and then right set. So right set is represented in form of rk. So rk is nothing but a right set, either read, write, print, execute, control, transfer, ownership, all this comes into picture. That means all the operations can be represented in yum, that should be belongs to rk. So all these operations, that whatever the operations we listed out, read, write, execute, all these must be belong to rk. So that is nothing but whatever we have as a set of operations, nothing but the permissions that should be belong to RK. Then only we can have that particular operation in that particular table. Then, so one of the demerit or drawback is the table could be large. So what is this? What will happen if the table is large? So that is, if the table is large, it is very difficult to fit into main memory. So we know why the requirement of main memory with the OS operating system, because whenever we boot up a machine, automatically the operating system must be loaded to the main memory to boot up or to wake up your computers. So along with that, if you have this global table where more number of IO devices and more number of software applications are available in your machine, then this global table will become little bit large so that it won't fit into main memory. If your main memory RAM is less in storage, then it is very difficult. That is one of the demerit. Second demerit is it is very difficult to group the objects, because some of the objects can be given access for n number of domains. So at that time, it is very difficult to group. So we'll give an example for this one so that you can understand better. So with respect to object, for example, so consider a situation in your laptop. So you have installed Microsoft Windows uh, as an operating system, under which you have my MS Office. So MS Office as a bundle, you have a PowerPoint presentation, MS Word, Sheets, Excel sheet, Access, and other publisher, all those things. So that is as a group. So entire bundle under a package saying MS Office, that is produced by Microsoft. So now consider the same example. For example, if in your machine, in your laptop, if you have more than one these kind of setup, then it is very difficult to group those objects. Saying that one cannot read the number of objects at the same time. That's why an object that all domains can read, it is very difficult to implement, very difficult to group. So why we need to group? Because to simplify and because to supposed to add it in the form of table. Consider domain, we have D1 to D5, 5 domains are there. Consider the object, around 10 objects are there, O1, O2, O3 up to O10. So then for each individual object, there must be write permissions, writes set, permission is write set, we call read, write, execute, or whatever it may be. So now, if each individual domain is having all those permissions for all the objects, then it is very difficult to group it. So that is one of the demerit, disadvantage. But again, we can come back or we can overcome about this one. So if you have larger main memory, you can increase the size of the table, global table. Or on the other hand, if you have more number of objects, then if you have more number of domain, so you can come up with this particular difficulty as well. So that is one of the possibilities with this. So there is, so in general, we can implement the access matrix in the form of sparse matrix. Sparse matrix is nothing but it will have only few non-zero elements. Only few cells will have non-zero elements. So if you consider an example, so we'll come back to this one. So this is an access matrix that we're supposed to represent. See here, only few are entered. Few cells have some set of values. So rest of all zero or null values, because it won't have any access permissions in this case. So if you consider previous setup, so we'll go back to the first one over here. So only few cells will have the set of permissions or rights. So that is what it means. So that is sparse matrix. Second one is global table. If it is global table, it should have a triples, nothing but 3 set of values it should have. The first set of value is domains, number of domains. Second one is object. Third one is write set. Write set is nothing but all those permissions, and it should be in this particular order only. So how to read if you have this kind of setup? That is a request operation M on object OJ within domain DI. Then we can look after the RK. That is how we supposed to read. Saying that we can have, if you consider as an example, we can have read permission on the object OJ by the domain DJ. Second option is we can have a access list for objects. So when we say access list, it should be an ordered list only, should have a sequence number with the number of objects and then domain. So now when we say access list, it should be ordered list and ordered pairs only. The ordered list or ordered should consist of ordered pairs. So in which the order should be, the first one should be the domain, the second set should be the rights set. So we'll see that. So now with respect to access list, each column implemented as an access list for one object. Saying that, please make a note. So it should be one access list for one object. So each individual object should have an access list, because each object will notify based on which are the domains will access based on the permission. That's why each object should maintain separate access list. So how to deal with that access list? That is resulting per object list. That is what I trying to highlight. Per object list, each individual object should have its own access list. It should consist of ordered pairs in the form of domain and rights set. So when we say domain, say D1 to DK or DI, number of domains, rights set, again read, write, execute, print, transfer, ownership, control, transfer, everything, all those. And including supposed to define with the non-empty set of access rights for the object. Nothing but consider if a particular machine is having around 10 to 50 domains you have. So it may not be sure for all the 50 domains you should access one particular object. We are not guarantee. But with respect to access list, it should have all the entries for all those 50 domains. Then we can have non-empty set of access rights. That means for all those access lists and for all those objects, it should have an access list. In that access list, whoever the domain wanted to access, those entries only have to be written in that access list. That is what this particular terminology means. So that should be even in ordered. Say if you have 50 domains, the first row starts from D1, D2, D3, D4. First one D1, second row D2, third row D3, and so on up to 50th. It should be in ordered pairs only. So that is second part. Third part is we can easily extend to contain default set. For example, consider the similar example. Still 50 domains we have. Sometimes it is not sure whether that particular domain wanted to access that particular object or no. Then we can have a default set. That means just to read permission, allowing access. So for this particular setup default set, that means we can give an option of switch statement in C or in C, right? So with respect to switch statement in C, it is nothing but multi-branch statement. So whether the particular user didn't input a particular choice, then we can set up a default value saying that whatever the default value entered by the user should be given prompt message. Similarly, over in this particular access list, so we can set up default value saying that only read permission can be given. That is how it works, the access list. Hope you cleared. So the previous one is global table with the 3 set of ordered values. First one is domain, object, and right set. In this case, access list nothing but individual object should have individual access list. So in that access list, we supposed to sort out all those domains with the proper rights set, proper privileges. So how to go with that? That is, each column is nothing but access control list for one object. So how to implement that one? So domain, you can see an example over here. So defines who can perform what operation. Domain 1 can perform read write. Domain 2 can perform read. Domain 3 can perform read operation. Nothing but, however, as per in our access list, it should be in ordered list only. Ordered list only. Please observe domain 1, domain 2, domain 3, and so on. So domain 1 is read write, domain 2 is read, domain 3 is read again. So it should be ordered list, ordered access list should have domain and rights set. So this is a rights set, nothing but privileges. And each row is nothing but a capability list, like a key, saying that each domain, for each domain, what are the operations are allowed on what objects. This is what that particular line, particular row means. Consider this as an example. Domain 1 equal to read and write. So we have against that object F1. Consider as a situation. So that means how we can read for that particular object, domain 1 can perform read and write operation. Object F1 as an example, object F1 that is only for read. Object F4 one can perform read, write and execute. Object F5 can perform read, write, delete and copy. So this is based on each domain, saying that that particular access list should have all those domain entries with their access list, should be in ordered format. So here also you can observe clearly, you started from F1, then F4 and F5 as an example. It should be ordered. Then third option is we can have capability list. So capability list for domains. This is the third one. First one is global table, which is having three values or triples. First one is domain, then object, then the set, permission sets or privilege or right set. Second one is access list, which is nothing but each object should have its own access list. In that access list, we are having domain name or domain value and rights set, nothing but permission. The third option is capability list for domains. So with respect to here capability list, so we are concentrating on domain, not for the object. So in the previous case, we are concentrated on object because each object we are going to set for its domain and permission, that is for access list. So in this capability list, we are trying with the domains. So instead of object based, list is domain based. Capability list for domain is list of objects together with the operations allows on them. Please remember this particular line, very, very important. So capability list for domain is list of objects together with operations allows on them. Nothing but it is again a form of list where each domain will have list of objects along with its operations. That means one particular domain can access how many number of objects and in what format. That is what we are trying to say. Say we have D1, D2, D3, three domains we have. Say we have again three objects, O1, O2, O3. So for each individual domain, we should have an entry with all the objects and operations. What are the operations are allowed for a particular object by the domain. That is what capability list is. So how to do that? So object is represented by its name or address, that is capability. So we are going to represent a single object in the form of name of the objects or address of the objects. That is nothing but a capability. So how to perform? That is execute operation M on object OJ, process request operation and specifies capability as parameter. So what to have in capability? Capability is nothing but you should have a list of objects with its operations. So just concentrate on this first part till here, this particular point. Please follow my screen. Execute operation M on object OJ. So we supposed to write this particular list as capability list, saying that what are the operations are allowed on this particular OJ. That is what the capability of that particular domain. Second part, possession of capability means access is allowed. That is by default. So whenever we say read operation on object OJ by domain D1, by default the meaning is for domain D1 read operation is allowed on object OJ. That is what the meaning says. Then capability list associated with the domain but never directly accessible by the domain. Each individual domain cannot access individually or cannot access directly. Once the list capability list is prepared and we are going to assign it directly, it is not directly accessible by domain. So not directly one particular domain can interchange, or one a particular domain can look after any other objects. Whatever the list is prepared, based on that particular list, the domain should act. On the other hand, it is nothing but a protected object. It is a protected object maintained by operating system and accessed indirectly. We can say, on the other hand, we can say it is nothing but a secure pointer. So what is this great in this? What are the greatness in this is, main part is security. Second part is, this particular kind of setup can be extended up to all the applications. Whenever you are trying to install new applications, each and every time, your operating system may ask you the question saying that whether you wanted to give all this permission to this particular application, whether you wanted to add in this preferences, whether read permission is allowed from your D drive, whether write permission is allowed on E drive or C drive. That is what the security is concerned with. So here the more weightage is given, because for example, if you already have Microsoft Windows or any other operating system in one particular drive, it is very difficult or not possible to install another operating system on the same drive. That is with this particular security capability, because you are already given authority to do alteration, modification, anything for that particular operating system initially with the one particular drive. So that second operating system by default will ask you whether you wanted to overwrite that particular drive, because you already have one operating system on that particular drive. That is what security means. On the other hand, you are going to protect that C drive. You are going to protect it manually, saying that it is protected object. On the other hand, if you do an exercise, so if you already have a Windows operating system in your laptop or uh, computer, go to C drive where you already installed, not C drive or any other drive where you already installed Microsoft Windows. Open that C drive, go to programs, and you can have whatever the applications you already installed in your machine. Okay, that is the list of applications you already installed, saying that you are given access to your C drive for all those applications. That is a capability list. If you take this as an example. On the other hand, you are given, while installing this one, you agreed for all their terms and conditions. You do tick mark. You'll do tick mark on that particular checklist, whether you agree or disagree. While installing, it will give a prompt saying that whether you agree or disagree. Right? So that is how it works. So first one is global table, second one is access list, third one is capability list. Fourth one is lock key. The fourth option with the implementation of access matrix is lock key. So this lock key setup is nothing but it is something like in between access list and capability list. There is compromise between access list and capability list. So over here, what happens is each object has a list of unique bit patterns called locks, and each domain has a list of unique bit patterns called keys. Now, key and lock should be paired so that each domain can have permission, specified permission on the particular object. Please go check this third point. Each object has a list of unique bit patterns, that is called as locks. Next point, each domain has a list of unique patterns called keys. So now, how to deal with this lock key concept is, as a pair, each object that is in the form of locks is assigned with the particular domains, saying that only few domains can access with few objects, or all the objects are assigned to all the domains. So based on our lock key process mapping. So now, so it can access whichever we pair with this, whichever matching occurs in between this one, then only you can carry out the access. Process in a domain can only access object if domain has key that matches one of the locks. So I want to clear more little by giving an example. For example, you have Bluetooth application in your laptop. You have Bluetooth application in your Android mobile phone. So now you captured a very nice photograph, very nice snap of your friend in your mobile, and you wanted to put or you wanted to share that particular photo with your laptop. So you know better, you have Bluetooth in both the devices. So you both turned on Bluetooth, and your Android mobile phone will start searching with the Bluetooth devices with the nearby location. So before sending that, both Bluetooth applications, even in Android and even laptop, should understand each other, saying that pair. So in that particular device, we use the term pair. In computer technical terms, we use the term pair. Nothing but it will share a common key in between, so that if a mobile phone is initiated with the request, then it will highlight a particular key value in the screen, and same key value should appear on your laptop's message box or front window. So if the values are same, you are given right permission. We'll go with yes, accept, receive the file. That's all. So now consider the situation. Your Android mobile took initiation and sent up key to your laptop. Laptop received that particular key and cross-checked with you whether both the keys are same. So now pairing match has occurred. Similarly, over here lock key concept, we supposed to map or match with the keys and locks. So now with respect to this lock key setup, domains are treated as keys and objects are treated as locks. So this is we supposed to match or map. Any clarification so far? We'll take a small break. We'll come back a bit later. So please go through once again. Let me know if you have any clarification on this.